Welcome everyone to YourDesk University, bringing you live learning with AEC tech experts directly to your desk. My name is Tim and Hazel. I'm a senior technical designer at Walter P. Moore. Tonight, I'll be your host as we kick off this series for the third time. We have already had two incredible sessions talking about Dynamo with John Pearson and 3D PPE making with our panel. If you missed those, make sure and check out those links. I think they'll be posted in the chat. The open source community has given us so much, and in return, we give you this, a high quality training opportunity right from your desk, and it's all free. If you're tuning in live, don't forget to use the chat on the right side to ask questions. I'll try to include those as we go or get to them at the end. We've had so many good conversations based on the questions that come in from there, and we'd love to hear what you're thinking. In our lineup after today, we've got two incredible sessions. We have AEC Designing Culture with Aaron White from Walter P. Moore, Ryan Cameron from CMBA Architects, and Cesar Escalante from Gensler. They're going to talk to us about how they have experienced change and how they've created change within their companies. I think it'll be a really good panel. And on Tuesday, we have Peter Mitya from NBBJ. He's going to talk about creating and maintaining useful code libraries. He's really experienced in our industry, and I think you'll love what he has to say. And today, we move on to a discussion based on Grasshopper visual scripting. If you haven't tracked the development of McNeil, they have completely rebuilt their platform to work on top of other applications like Revit. Wow. It was something our community needed and wanted. Thank you very much, McNeil. This is a huge improvement to our daily work. If you agree to this, go ahead and post something, because I'd love to give them a little bit of energy in that way. And now to our speaker, Kadim Alasady. He's a no-nonsense kind of guy. He's going to show you things just as they are. This architect by training now supports a team of structural engineers at Walter P. Moore, and I'm grateful to have him as a coworker. He teaches design studio and computation and data visualization at the University of Kansas, and I'll let you tell them a little bit about your current side projects. Kadim?
Hi, everyone. Thanks for joining me. So thanks, Timon, for that introduction. I guess my side project right now that's taken up a lot of my time on top of, just Walter P. Moore and then teaching is I'm building a mixed-use project, the GC on it. So I'm actually doing like the concrete and I'm framing and all the finishes. And it's just this thing that I kind of stumbled on. It started out with a tiny home and then it expanded to 2,600 square feet. So that's where I'm at.
So you're
right
working
now.
a full-time job, teaching classes, and building your own home on top of this mixed-use facility that you're going to rent out. Is that what you're telling me?
Yeah, I'm trying to do this. I don't know if I'm actually doing them successfully, but I guess the end of 2020 will tell me that.
All right. Well, cool. Thanks for sharing
Yeah,
that.
you bet.
What do you have prepared for us today?
So let me share my screen here, and I think we can just dive into it. So I've been with Walter P. Moore now for over a year, and since I've joined, I been working on a lot of like arenas and stadiums. And the thing that kind of became increasingly clear is that these projects are really, really complex geometrically, but they're also repetitive and they're constantly changing, especially in the early design phase. And one way to kind of optimize workflows is to develop some sort of script that could flex based on design changes from our clients. So, and diving into Grasshopper and just working and reworking bits of scripts, eventually that kind of developed into the development of this set of clusters that helped me kind of build a stadium structure. So what you see on my screen right now is just an east wing of one stadium that I completed. And this entire thing was just simply automated through a Grasshopper script. So just to give you a preview of the script basically takes inputs such as structural grids and top of canopy from the architectural model, and then it generates this point cloud. So I'm kind of feeding into the scripts how I want to dissect the stadium, east, west, north, south, and then whichever corners. And then I kind of take this point cloud and divide it into levels. and the levels into grids, and then take the grids and then basically connect them. So each component that I'm clicking on here is a cluster that kind of does special things on the inside. And so as we work our way around the stadium, you see that the whole thing kind of gets built over and over again, utilizing really about, I don't know, 8 to 10 different clusters. And obviously for different parts of the stadium, I had to develop, other clusters that were project specific or part specific. And eventually you kind of get the stadium. So that's where this whole power, like at first when I started, I was just kind of scripting with just Grasshopper nodes. And then the idea of clustering and laying out the cluster along the structure of the stadium became increasingly apparent to me as a way of troubleshooting, because after the thing is set up, really a lot of the time is spent troubleshooting. So today, what I would like to demo is this simple structure. And I know this is not as exciting as the one that I just showed you. And it's not as exciting as other ones I worked on, but it really, I think, helps demonstrate how simple the setup is and how it could grow. The complexity of the structure could grow, but the setup could still remain simple. So let's go to this other screen here. And this is the script setup for this small structure. And now I want to kind of run through about 10 minutes or so and building it from the ground up.
Before you get started, I noticed something about your script. A lot of people have linear scripts with groups. Yours seems to be more collected into one area. Can you talk about that just shortly? About how you use the lines to kind of like...
Yeah, so that was actually a kind of a learning curve for me, because when I first started out, I'm very used to kind of data flowing downstream, and this is how I troubleshooted it. But given how complex this script is, or there's just so many components to it, it was easier for me to troubleshoot. Like right when I select all these nodes and kind of I get the preview in my Rhino window, if there are some lines that are kind of connected incorrectly, I know right away. So let's just say that there's some random member connected to this corner. Well, now I know in my Grasshopper window that corner right there is this point right here. And this is how I'm able to quickly go to the part of the script that it's throwing an error, instead of having to kind of work, backward towards the beginning of the script. So just visually organizing the script based on the structural layout, I just found it very, very helpful in troubleshooting. And that's how this kind of arrangement came about.
Yeah,
so
thanks.
It's completely confusing. It just, the wires all overlap each other. Is that good?
Yeah, but the pink lines, they kind of like help you lay out how to troubleshoot. Is that what you're saying?
Exactly. Yeah. So again, as I said, that as I highlight the structure, if I see that there's something wrong here or on the canopy or along the raker, I know right away where to go on my script to kind of, troubleshoot that part of the geometry.
That's kind of cool. Thanks for letting me interrupt you for a second there.
Yeah, no worries. Yeah, I mean, if I'm not seeing this chat, I know you told me that there's a chat, but if there are other questions that come up, interrupt me all you want. It doesn't bother me at all.
You guys heard that. Let's go for it.
So to today's script. So this is kind of the KC tab that I developed. I'm at the Kansas City office, and these are all the kind of clusters that I've, developed over the last year and a half or so. So the first thing I want to read is the grid. So where is this grid file coming from? Well, that's an Excel file that I generated from Revit. So I can just go and select my Excel file here and plug it into here. And then now I also want a levels file, and I also extracted levels from Revit. And then I want to kind of just read these files. So now I have these simple grid. The levels are not going to show that much because they're just numbers, right? This is the level elevations, and the grids are right here, just the grid index. So I just have longitudinal and transverse grids. Now you notice that the levels are kind of off. So what I want to do sometimes per project, I want to dive into this cluster and study what my levels are doing. So if the project manager, the project engineer I'm working with they require a specific offset from the level, this is where I kind of consider those offsets. For right now, we're just going to simplify this and just plug the native Revit values so that I could just read those. And now they're kind of organized from 0, 60, 162, and 546. And that's good. So now the next step is, I typically don't know how my grids are sorted. So I kind of developed this cluster that takes the grid geometry, which is just the curves that represent the grids, and the name of the grids, and sorts them based on transverse and longitudinal. And this is where I type in which grids I want to divide up. So if you remember back earlier from that stadium, the largest stadium script, this is where I put in, like, for example, this was my east wing grids, longitudinal and transverse. And so I do that per grid or per wing so that I can divide up the stadium or the project accordingly. So this is how I kind of sort these grids. And then next, I want to plug these grids that I sorted into this other cluster that generates this point cloud. So my transverse grids and transverse index, and longitudinal grids and longitudinal index. And the last bit of information that this thing needs is my elevations. And now I have my point cloud. So now I'm ready to kind of take this point cloud and divide it up per level. So I have this other cluster here that takes the grids, the points and the point index, and divided it per level. And what I want to do to list out level by level is basically just create a value list for L1 equals 0, L2, L3, and so on. And plug that into here. And you see now I'm visualizing it level by level, level 2, 3, and 4. So the last step to break it apart is really to visualize it grid by grid. And this is what this thing is. So this is assuming that there are 7 grids along the longitudinal axis. And one last bit that I kind of stumbled on is that I realized that there's so many parts of this stadium that a lot of times I was using an index to build another index. And so the index for our kind of digital workflows is really, really pivotal, because every element, whether it's a point, a column, a brace, a strut, has a unique index identifier that somehow relates back to the project, grids or levels. And I found myself a lot of times splitting the geometry element from the index element to manipulate the index element so I can apply it to a new geometry element. So this is where this cluster came in, where automatically the point and the index are kind of split together. So now I want to kind of separate this and plug it so that I could get the 3 different parts, the 3 different columns. And now the last step is I basically need to take the set of 3 and then change their level.
So you're kind of like getting the points and at each of the levels kind of projected to each level.
Exactly. So you can see you can start to see that the stadium is being built up, right? Did I delete this thing? Oh no, I didn't. So you can see that from this front view, you can see that my points right now are kind of roughly matching the grid of points on my stadium. So this is why eventually, depending on the complexity of the project, I actually take this view and bake it into my Rhino or my Grasshopper window so that I can organize the nodes and components along that grid so that it could help you troubleshoot. So for example, I know that this point is useless, so I just delete it. There's no need for this point. So now it's time to connect the points to create the actual, curved frame that will eventually translate to a Revit element. So I need columns, and this is a column cluster component that basically takes the points and the indices and builds a column frame. Now, the last bit to this is the base of the index. So I also developed a way to kind of create a drop-down list of a base index. So this requires a building or a site. So for example, I'm going to call this YouTube stream. You could call it whatever you want to call it for your project specific.
So you're naming your points and naming your lines as these like text indexes.
Exactly. So my points are already named. My points are always going to be named PNT for point, right?
Gotcha.
And then it's going to give it the specific, like if it's a point at level 0, it's going to say point underscore L0 and so on. Now I'm building a unique index for my actual.
I've got a question that
frames.
came in on the chat just now. What are these components you're using? I'm used to using like lines and things like that to connect points, but you're pulling these other components off. Can you say a minute about where those components are?
Yeah, so these are clusters that I've built. Like every item here, I just gave it this very fancy icon. I just created this graphic, but if you double click it, it's a bunch of native Grasshopper components, right?
That are
So
just clustered inside of there.
They're just clustered inside of this. So then I save them as a user object so that I can create my own tab, and I can just quickly go to my own tab and just, it's kind of like a shopping cart. I have these tools that I go and just, retrieve an item from the shopping cart as I need while I'm building the script. And so what's inside these scripts, there are some like basic expressions, and there are some that have even nested clusters that are even simpler. And there are some that have like C# or Python scripts, but 90% of them, they all utilize native Grasshopper nodes.
So you've already put something in there that's kind of like draw the line and connect the points and all these things that are inside there, and that just generates the column. I think that answers the question on the chat. Thanks.
Exactly.
You got an impressive. Back to you.
Oh, thanks. So anyhow, so this is my list of kind of all unique elements. And this is something we kind of developed in the office, right? Like, so this is a beam, a girder, purlin, column, and so on. And so instead of listing this through a list item, I found this really cool plugin online. I can provide a link for it later. I actually don't. I forgot the name, KT, but I forgot what KT stands for. But anyhow, it gives me. I downloaded this like a year ago. It gives me a dynamic dropdown instead of having to kind of constantly select an index value to go to the item that I need. So in this case, I want a column, and then I want a beam, and then I want to take this column base index and plug it into my base index for my column frame. Now I can take this and copy it and build the second story of my columns. I can take these two and copy them over and build my second grid of columns. And then I can take this last one and copy that over. So now I have all of my columns built, right? So we could just turn off all this stuff here because it's kind of distracting. So now we're ready for the beams. And again, if I have another framing, so I kind of try to match it based on the Revit lingo. So this is create column and create framing. Revit just distinguishes between column and framing, and this is how that develops. So again, this asks for a base index, and then a start point and a end point, and there goes my beam, and then you kind of just repeat that over and over again. Now, I have developed other clusters that I haven't really been able to flush out as these to kind of take all, it's like I know if all of these are being connected, like this row, and that row, then I can just feed it multiple inputs instead of having to repeat these components 3 times. But also, this is just very project specific. So some projects, this member is going to be a different sectional profile than that. So this is where you feed in a Revit section profile. Let's just say it's a W 12 by, I don't know, 44 or something. And that would be programmed into the index later when we export it to Revit. All right, so one last bit is my raker. Let's build that real quick. There goes my raker. How am I doing on time?
You're doing pretty good. You're about 15 minutes in.
Oh, sweet. Oh, sweet. Okay, nice.
I ate the first 5 minutes up with my intro, so you're good.
Nice. So last thing is I want to build these girders, right? So I want to first go and change my index type to girder, plug that into here. And this cluster you can see is still in development. The ones that I fully flush out, I apply this fancy icon to just so it can give me a visual reference that this is somewhat completed. With even if you hover over it, they'll tell you what that input is describing, or some of them will also tell you what the inputs, what are the applicable inputs, and what each applicable input means. But obviously, this is all just a work in progress. So,
Yeah.
so this
How do you get those inputs? How do you get those previews to show up on the inputs that tells you what the allowable input for that is?
I mean, on this, so in Grasshopper, you get this input like node for clusters, and you can double click on them, and you can type in a name, nickname, and description. And the nickname is the abbreviation. And the description is when you hover over, it'll give you an expanded description. And then the built-in site, that's the name in parentheses. So if we go back here, so if we get a regular, no, this is
any node has a preview on it. I just wasn't sure how you got it
from
on
Grasshopper. You see where it says base parentheses B? That base is the name. The B is the nickname, and the item below it is the description. And so this is how this looks like a native Grasshopper node or a scripted node, but it's really just a bunch of native Grasshopper nodes that are kind of clustered with these to make them look like that. And it just saves me a lot of time and space instead of having to go through all of this. Okay, so back to these girders. So what this cluster does is it takes these points and it basically shifts them, right? So it takes these set of points, eliminates the first one, and it gives me just these 4 as my point B, eliminates the last one, it gives me the first 4 as my point A, and then I just plug these into here, and then I have my girders.
Yeah, how many times have I like put the shift list node on there and set the settings so that it worked the way I wanted it to.
And I have another cluster. Unfortunately, I couldn't remember which project I worked on. So that instead of right now, like I have to basically plug this over and over again at each level. A lot of times these kind of girders are like typical in size and they're the same section profile. So ideally what I'd love to do is just combine another set of points into this. But obviously because of the way the points are shifted, it won't give me the exact preview. This is actually an excellent, what happened right now is an accident. I didn't intend for this, but this is what I'm talking about earlier. If there's an error, like obviously there's not a cross brace in the structure. At least my engineers didn't tell me. And so if something like this happens, this is where the visual setup of it really helps. Like I know now that there's a problem at this node and that node. So in my visual setup, I know that it's going to be this one and that one. And I can quickly dive, from my zoomed out script, go into where the problem is and troubleshoot it instead of having to kind of navigate the entire script for a large project and figure out what's going on. So I'm going to disconnect this guy and then just continue building this. We're almost wrapping up here.
Yeah, you've basically built an entire section of a stadium in just 15 or 20 minutes with like 30 nodes. That's really cool.
Well, there are 30 nodes. So far, this column node has been used 5 times, and this frame node is 8 times. But there's not really that many nodes. This point nodes is 8. This is 4 times so far. So far, we've only really used 6 nodes. We've used them over and over again. And at least that's my hope to get out of this. And also, like if we were to just explode all these clusters, you can, by the way, you could just right click and say explode. Really try not to do that if I were you. You could see how really messy this script can be, right? So this is where I kind of earlier took all of this and just took a little bit of time and reorganized it and laid it out along this structure. So I just baked my frame in from Rhino to Grasshopper and laid it out so that now, like I said earlier, let's say I or one of my team members accidentally connected this and I'm visualizing this, well, I know that there's some sort of problem there, right? And so I know that the problem is at that point and that point, so I can quickly zoom in and say, this is where my problem is. And so these 2 nodes are connected to that. and that is connected to that, and there it is. That's how I kind of navigate through a script. Again, with this demonstration, this part of a stadium, the simple structure is pretty simple. Maybe this is not required, but on the previous one, you could see that it could get really, really complex.
You're getting compliments on your icons in the chat, by the way.
Oh, thanks. Yeah, I mean, it's just beauty of Illustrator. So the last thing I want to demo, building on this. So this is on my personal, like this is the project side that I'm working on, like my,
before you jump into the other example, can you show us really, I don't know how long it takes, but can you show us how to make one of these clusters and put it onto the control panel?
Sure. Yeah, totally. Let's, so let's see, what do we want to do? I want to create a cluster that says, type in your name, maybe. I don't know. What should we do? Do you have something in mind?
I don't know. Let's connect two lines and connect two dots and make a line. I don't think it gets any more basic than that, right? Everyone can follow.
All right.
Along.
So I go to curve, line 2 points. Obviously the line is going to require 2 points. So I need 2 points of input. So if you go to the params tab and utility toolbar, there is the cluster input. So I can double click here and say, this is point A. This is going to be point B. And I could plug that into here and here. And then the output would be my line. So this would be line L.
Again, this is just, super simple, but at least it shows
this
us
is really simple. How
to make these clusters that you're putting on the toolbar.
Yeah.
On the panel.
So then you select them after you establish your inputs and outputs, and assuming that what's inside your cluster is something a bit more complex than just one node, that would be a waste of a cluster. Just click cluster, right? So you just select all of it, click your mouse wheel, and click on this cluster node, and that clusters it. So if you hover over that, it says point A, and in parentheses PA, and you can add a description. By default, it just says line start point, because that's what it plugged into, and the native Grasshopper node. So now this is asking me that I need a point, so I'll go to vector and go get a point. And let's take another point here and give it some sort of value. And there goes my line.
And can you show us how you get this onto the panel at the top? I think the viewers would find that really helpful.
So if I take this, if I select my cluster, you can go to File and say Create User Object. And so I have you want to name it. I would strongly recommend being as specific as possible, because it can get really out of hand very quickly, and then you're basically just trying to drop a lot of items that are clustered that you have no idea what you're dropping. So I'm just going to creatively name this line again, and line one more time. And I'm going to categorize it under the KC tab. So I can categorize this under any of the tabs that are available in your Grasshopper window. And I classified it under KC, Kansas City. And the subcategory is structure. In this case, I'm going to call this YouTube live stream. And you could click on this icon. I don't want to, because it takes a really long time to select a fancy icon from an available list of icons. Or you could load, this is browse for an icon, and this gives you an icon library. I don't want to do this because it takes a really long time. You can just say, okay. So now if I go to my KC tab, I have YTLS new toolbar created, and that has the line component in it.
So everything you've created, you just export like that, and then you can import it on any other project that you needed.
Yeah, so if you go to your File, Special Folders, User Objects, here are all of my special user objects that I've created, and that line component is there. So if I click that and delete it, or if somebody is just cleaning your drive and they delete everything, then it's gone.
It goes away. Yeah.
Yep.
Cool. Thanks.
That's it. Yeah, I mean, it's really easy. Again, the problem with clusters, you have to understand, is that if I do something here with this, right? Let's just say I add a giant panel. Let's make this really, really obvious. and then save it. If I hover over this, you see it gives me a preview and that giant panel inside of it.
Mm-hmm.
If I go and get, what is this, the grids? If I hover over that, it's not showing me like, because if I go get a component from my tab, that component is getting the component that is stored in the special, the object, the special folders of object user objects, right? So whatever update I do in my screen doesn't update that, not unless I say, okay, it's time to update that component. So I kind of delete this one, go back to my special users object. And so this is my read grid cluster, delete it, and now I can save it as again.
Okay.
Create user objects, and it will remember all of the information, say okay, and now, did it not do it? Oh, that's, give me a second.
You gotta love oh, there it is. It's on the far right side. You grouped it under YTLS.
Oh yeah, see, I didn't change the category, but yeah, see it updated.
Gotcha.
Yep.
Gotta love live demos.
Yeah, something always messes up.
We have another question on here. Yeah, that's awesome. Right. I think that's really useful for people. We got another question here on, can your colleagues use these same clusters that you've already developed, or is this pretty much just for your personal use?
So we have developed techniques right now. These clusters, not a lot. Well, there's one person, the Atlanta office. Oh my God, he's not gonna like me for forgetting his name. I know his name. I promise I know his name. It'll come to me at some point. I'm blanking on it right now. But he's using some of the clusters. I've shared the entire library with him, and I think so far he's loved it. And there is a way we've discovered to kind of create like a shared library where we're constantly updating to it. But I still think you have to kind of constantly go to that shared library and then download the new iterations of these clusters and update them, if that makes sense.
Okay.
But yeah, it's definitely. The other thing that I've also done is, if you notice in my original stream, that these are all the clusters, but my initial parameters are kind of coming in from the outside. So this is referencing a data file. And that's because this stadium has, like, I think from the script, it generated like 2,400 members, steel members, with all their properties, like section profile properties, and sometimes some of them had releases. So it was kind of difficult to combine everything in just one file. So what I did here is I kind of actually started using this data input and data output nodes that Grasshopper provides, where I could feed data into my existing Grasshopper file from another Grasshopper file, so that if I'm working on a large team and this is a large project, we can actually split off, like break apart the actual structure and give, like, you know, one of my colleagues can get the north end, I can get the east end, somebody else can get the southwest corner, and so on. And so we're constantly referencing the same parameters file. We're kind of performing our own work however we see fit. And then we're all exporting to a shared stored file that gets referenced in an overall file that builds the entire stadium.
Gotcha. So they all gets parsed out and then brought back together.
Exactly.
Okay.
So we all have the same starting point. So we're starting out with the same data set, the same grids, same levels, same divisions, same indexes. And then we go to the same spot. But in between, we can kind of have our own kind of creative autonomy to how we, you know, set up the script, what clusters to use, how to connect them, and so on.
Gotcha. All right, I interrupted you as you were moving on to something else, and I know we're getting close to wrapping up our time. You've got a couple more minutes to go, and if we get more questions, I'll ask you to stay longer. We'll see how that goes.
Sure. So building on that knowledge of clusters and all that stuff, I'm building, as I said early on in the introduction, I'm building my own, developing my own project that's like mixed use, commercial and residential. And part of me cutting costs is building all the casework. So this is how one of the kitchens is laid out. So this rectangle here represents the back face of the cabinet that I got from Revit. So I exported a Revit model. I don't know if I have the Revit model here. Let's see if I do. Maybe not. Yeah, I don't. Oh, so I actually do. So this is what came out of Revit. This is just an extrusion in Revit with lines. And then
Okay.
from there, I kind of extracted just the rectangles. And so then I developed these more clusters that reads a curve. So it's reading all these curves and it's selecting one curve at a time, right? So this is the curve I can go through and select any curve.
Mm-hmm.
Go back. I think this one is more impressive. Okay, so I can select this middle cabinet, and it also requires a divider curve. So this middle curve, this is telling you if you want to divide this cabinet like in 2 doors, where do you want to divide it, right? So I can go to my right elevation here. I can just select this and move it. And then it's asking you for a direction. So which cabinet is this facing? So from my Revit window, this is my island. This is the face of my cabinet. So the face of my cabinet is pointing that way. So I basically just, did a vector that points and -x and plugged it into this cluster. And inside this cluster, what this thing does is that it builds a cabinet, and it builds a fabrication level model with all the joints accounted for.
And this
And
is what you're doing
then
on your free time. Is that what you said?
this is what I'm doing on my free time. This is what I'm doing for my project, right? So this is the doors for the project, and you could choose between single or double doors. And then, as I said earlier, that this line and elevation, you could just move this line and it'll update the door geometry.
Okay.
And then this right here builds the shelves. So then it combines all of it so the shelves here are really just pegs inside the side wall of it. And then this thing right here flattens all of the pieces for CNC milling. So I can just make it. Now I'm not done completely with this because the idea is to do sheet optimization eventually that hopefully I'll get to by June, because this is when I need this.
When you're paying for your own plywood, you really want to optimize the space, right?
Yeah, I can't waste. Like this is crucial. I can't, believe it or not, I'm building all this casework for under $5,000, and that's because it's all being CNC'd, and I'm doing the CNC. I'm just paying for material. So the last bit here is I developed these other set of clusters for my base cabinets, and these build drawers, which is just awesome. At least I think. I think that's all I have.
That's pretty cool. I don't know. From the chat, is that all he has, guys? I feel like that's like a ton. You just talked about building a stadium. You talked about mill order level cabinet shop drawing or cabinet. What do you call these? I guess fabrication level pieces.
Yeah.
That's kind of cool. Got a couple questions here to throw your way. One, do you use remote control panels inside of Grasshopper at all, where you're able to like send from point to point?
Yeah, I have, and I have an excellent script that can demo that, but unfortunately, I don't think we have time to actually. But yes, I have. So this is a project that I worked on.
What are your thoughts on them? Do you like them in general? Do you kind of try to avoid them most of the time?
I think a lot of times for me personally, I try to avoid them because I just like to be in the script environment. But I think if you're demoing something for just a presentation, like a client presentation, or even just like a kind of an academic presentation. So I worked on the script for one of the engineers I work with, David Runzer, and we with his help, we kind of developed this visualizer that visualizes the cross section and the rebar design layout of a grade beam.
Okay.
And he didn't want to see any of the script. Like to him, the script, as long as it's giving him the right output, what's happening in the background, it's kind of irrelevant. And I'm hoping that that's where we'll get to. Mm-hmm. So I kind of fed all the sliders and the inputs into a remote control panel. And when he demoed it to his design team, he kind of demoed it by just previewing the remote control panel. So I thought there was an excellent use of a remote control panel.
Very cool. Yeah. We got a couple more questions here. Building off of Kyle's question, how do you feel about, or are you able to send any of the stuff back into Revit? Are you able to use Rhino inside for some of the framing, or how does that work? You talked about kind of sending it into a separate script, but do you use Rhino inside at all for getting anything into Revit?
Yeah, I mean, since Rhino inside, that's actually decreased. Not that I've really used Dynamo that much, but it's decreased my Dynamo consumption by like 90%. Like if I could figure, I'm just I'm just more efficient to Grasshopper. So if I could figure out a way to use Rhino inside and Grasshopper and Revit, I would do that in a heartbeat. So to that point, how all this like stadium stuff goes, that directly translates to Revit. At the end, what this thing outputs is a an a data set. It's an Excel spreadsheet that has that each row corresponds to a unique member. So this Raker member has an index, has a section profile, has releases, and so on. And that eventually goes through another script and Revit to build the actual stadium structure in Revit. So, excuse me. So if design changes happen, which happened on this project, at some point, this whole back grid shrunk by, I think, 2 feet or so. And in Revit, controlling all these points, it's not that it's impossible. It's just really, really painful and tedious. Here, all I had to do is just upgrade the grids file, because that grid shifted back by 2 feet and the entire structure upgraded. And then all we had to do is regenerate the Excel spreadsheet and send it back to Revit, and then the structure upgraded. And because the indexes were matched, then it was just a mere update instead of a rebuild.
Straight into
Though
Revit.
I have done rebuilds as well.
That's cool. Another question here. If I'm a new person, and this isn't really the focus of YourDesk University, but if I'm a new person and I'm just trying to figure out how to get started in some of this, what would be 1 or 2 ways you'd recommend them learning these different pieces and the functionality at kind of the beginner level?
Getting started with Grasshopper?
Yeah.
Yes, there's an excellent source. So, boy, where is this? So there's this Grasshopper primer. This is excellent. So I teach Grasshopper and I download this book to my students all the time. Let's see, we could like do read online. You can download it as a PDF, but you can read online. And this goes through installing Grasshopper. If you're still using Rhino 5, Rhino 6 comes, Grasshopper comes shipped with it. But this is just goes through one by one, installing it, the anatomy of a definition, what's an input, what's an output, what's in between. I mean, this is
kind of helpful for everything, independent on if you're trying to do engineering or architecture, design, or layout.
Oh, totally.
It kind of like helps you figure out how to do Grasshopper altogether.
I mean, I think in my use of Grasshopper, if you don't understand how data is structured in Grasshopper, then I don't think you'll be able to use Grasshopper. You can probably put in sliders and make cool things happen, but you won't really be able to actually utilize the power of the software.
Yeah.
It would be failed. So the other source here is Grasshopper. I Eat Bugs for Breakfast is excellent. That's the original developer, his blog. He has excellent long form articles about the inner workings of Grasshopper. But then there's also the Rhino and Grasshopper from McNeil, their developer section, and they have all the resources that you need right here.
Very cool. Thank you so much. We're about out of time, so I just want to say thank you so much. This was really cool. Appreciate you showing this to us and then making it pretty accessible to people with regards to like trying to do it themselves, because you're showing 2 examples, but this idea of making these user objects, it can be repeated for anybody in any way. So thank you so much for that. And with that, I'm going to ask you for your favorite book or a book you'd recommend. So I'll try to give you a second here to think about it. But I'm going to put you on the spot.
That won't be difficult. Notes from Underground by Fyodor Dostoevsky.
No sweat.
Notes from Underground by Fyodor Dostoevsky. It's a novella, a short one, but I very much recommend reading that book, especially during a time like this. It has a lot of humor.
Thank you so much. Appreciate it, everyone. Right. Thanks for tuning in, and we'll see you next week for the rest of the sessions.